Marc.
Hey, how are you?
Glad to have you.
Hola.
Yeah, so this week, Rick, you still haven't brought your bass, but next week, right?
We need rehearsal, and then we're in.
Okay, yeah, but you need to set up some time to do that. Oh, cowbell. Okay, are you ready? Well, is that really a cowbell?
Yeah, I mean, I don't know.
That's like a real cowbell, or is that like dinnerware?
It's Hobby Lobby.
Is that something that you put your napkins in?
No, it's a bill.
Wow.
An IP69 box with a LoRa antenna.
Okay. All right, guys, let's try to do this. All right. We're going to do something for Stephanie. We're going to do a little bit of Texan rock and roll. Okay.
Oh.
All right. You want to give me a beat? Latin beat, or Latin beat's okay too. But can't hear.
There you go.
Stevie Ray.
Could you actually hear it?
Was that
Yeah.
ZZ Top or
Yes,
Stevie
we
Ray?
heard it.
Oh, no, that was ZZ Top, man.
Right. Okay.
Total 100% Texas rock blues.
You should have done a little Charlie Daniels band since he did
Yeah.
that.
Oh, yeah, no kidding. No kidding. Yeah, you don't think of everything, do you? On the fly. Totally unscripted, unplanned, but, you know, we do what we can, right? So hey, welcome. Glad you guys can make it. Look at Stephanie. Say something, Stephanie, so everyone can see your wonderful view.
Good morning from the Texas Hill Country.
Yeah, and so that tune that we just did, or I just did, or we did, actually, you have your little cowbell there, and you have your Mark out there in Spain, you have your LoRaWAN antenna, and what was that other thing? Was a modem?
IP69 box to prevent water to get inside the electronics.
Yeah, so one thing that we proved with that was, number one, Zoom is not a great platform for distributed music performance. And then number two, latency is a problem. So there's a lot of hope that musicians have for 6G, and hopefully 6G will solve that problem, right? But
have
Actually,
you seen all the wonderful performances that people have done on Zoom? And I'm like, how did they do that? There'll be like these videos floating around with like 20 people, and they're all singing or playing instruments or whatever, and it's like beautifully produced or something. I don't know how they do it, but it's amazing.
that's the operative word, produced. Produced. Yeah, and then they also use AI, or at least they claim to, which is our topic for today, right? AI in IoT, and I guess what we'll talk about today is the state of IoT, or AI today for IoT. So I don't know if anybody wants to kick this discussion off, but
I just finished reading Kai-Fu Lee's AI Superpowers. Cool book, by the way, if you haven't read it. Definitely worth the read.
Mm-hmm.
And he talks about kind of these 4 waves of AI, which I think are kind of a good starting point for the discussion. So it started with what he calls internet AI. Mm-hmm. I don't think that's necessarily a hugely relevant topic for us, but that was, mining user behaviors on websites and things like that. The next wave is what he talks about, business AI, where you're using structured data from enterprise systems and applications. Mm-hmm. While IoT data isn't super structured, it's part of the whole, mixing business data with it. The next one is perception AI, and I think that's actually a super relevant one for our discussion today. Mm-hmm. We talk about edge. I'm sure we'll dive deep into AI at the edge and so on. But that's like meta sensing, using audio, video to turn it into some other meaningful source of insight. Mm-hmm. Also, voice, language, things like those. And then the fourth, which I think we probably won't spend much time on because it's anywhere from 10 to 1,000 years out is true AGI, just totally, autonomous AI. But the first two, I think, are super important, right? Business context AI around structured and semi-structured data to get new insights, to improve processes, and then AI to provide new forms of sensing. Certainly the two big areas that I think of when I think IoT and AI.
I think that the interesting thing about all of that, what you just said, Rick, is that the theme across all of them, which is what we talked about, in the past few sessions, is data, right? In some form or fashion, there's something being fed, and then there's some kind of action that comes out of that that's not from human, right? So not from a human interaction or a manual interaction. So I think that's the common theme there, but I like how you've laid out the different 4 kind of categories because it makes sense. I mean, I think for all of us, and I think for me personally, since I do a lot of things in B2B, is the business AI is where we're seeing some of the most traction in terms of interest in businesses trying to really understand the applicability of AI to their business and how they could use simple tools now to make a move in that space. That they're really just trying to get their arms around it because first it's IoT, now it's AI, and then all of these things are coming together. And 5G is also something that's coming together with all of these pieces.
Yeah, but maybe we can take a step back and ask ourselves the question, what is AI? Because we hear this acronym. Oh, it's too early in the morning. I haven't had enough coffee. So much. And it's interesting because about 5 years ago when I was with Gartner, Gartner actually had this discipline of not calling things AI, right? Where everybody was putting pressure on creating a buzz around this term or this acronym. Gartner actually tried to hold the hype back, and to their credit, they tried, but marketing forces prevailed, and next thing you know, AI is everywhere. And this is about 4 or 5 years ago, and all of a sudden, you saw all these vendors start to come to market or go to market with this idea that their products were AI enabled and AI this, AI that. But what is AI? And in the context of what you just listed out, Rick, how does it apply there? Because early on, when I'd meet a lot of these companies that claim to have an AI-based solution, it ended up just being, some sort of BI tool. Big data. It seemed like a progression from big data and BI analytics to now this thing called AI. And there wasn't a lot of substance there. I didn't see anything too human intelligent about what they were doing. A lot of it was just pretty much old school, data analytics.
Sure. Well, there's a significantly growing trend to repurpose the term AI around augmented intelligence, right?
Yeah.
And there's a bunch of variants. Again, another book I'd recommend, Alex Bates' book on the topic. But, the way I view it is you've got a couple, some people will segment it into all the nuances of supervised learning versus unsupervised learning. I mean, at their core, they're numerical algorithms, of course, right?
Yeah.
The question is, what functions of the brain or human intelligence are we trying to reproduce? And everything from I think your next gen BI thing is sort of that offline eureka moment, right? You're looking at data, the machine is able to process pattern recognition at such a speed that some insight that wasn't apparent to you pops out. But that's kind of offline, right? Stephanie talked about the importance of closing the loop and taking action. Mm-hmm. So there's still a lot of that crunching. And I do think this whole meta sensing is a complete space of its own, right? That's where we're doing the video, audio, high frequency, high volume signal processing to glean some new insight. Super cool one I saw recently was, I mentioned it on a previous podcast, a company that's doing audio for hearing impaired people so that you can know that a baby's crying or an alarm is going off or water's running. So that's kind of the cognitive processing, or what Kai-Fu Lee called the perception AI, right? And then we've got like this, autonomous driving, sort of a natural evolution of that, where you're bringing very complex perception AI mixed with algorithmic control and decision making, right? Now it's human-like decision making, but it's this whole continuum, to your point, that we've all blobbed into one big thing called AI.
Right.
Sentito silenzio, Ara? Hey, so I just want to give you my 5 cents of my experience on AI. And actually, it's interesting that 15 years ago, I was doing my engineering thesis programming artificial intelligence agents, multi-agent systems at that time. That was the trend on artificial intelligence. And actually, I was programming these agents, giving them beliefs, desires, and intentions. So actually, it was a really interesting framework where you can provide to agents that were running autonomously with beliefs, desires, and intentions. And actually, 15 years later, what I see is that artificial intelligence algorithms are giving to people beliefs, desires, and intentions, so they can vote or they can buy. So actually, if I go on a very low, high level. So I see that artificial intelligence on specific use cases is working really well and doing what it's designed, at some point. But on the other hand, I on IoT specifically, I don't see a lot of interesting use cases. So what I have seen more working from my experience, it's predictive maintenance. With unsupervised algorithms, but not much. Everything else that I have seen, it's just application of algorithms and visualization of data, not more.
Yeah, so I have a question for you guys. What's the difference between an algorithm and just a coded program?
About $100 per day.
No, actually, an algorithm it's a black box where you introduce some variables and you get some results. Okay, right. So a bunch of code, that shouldn't be that, or can be a part of an algorithm or not.
Yeah, and so that's where I think some of the marketing teams out there need to know the difference, right? Oftentimes you hear people talk.
I'm sorry, go ahead.
Go ahead.
No, I was going to say, I think a lot of what is being called artificial intelligence out there is really more machine learning. And I mean, I've seen some interesting use cases. They're actually being talked about, but I don't know if they're actually, being implemented or scaled. And things like the use of camera and vision, machine vision to identify criminal activity that might be happening in the streets, or listening to gun.
Oh, wait a minute, Stephanie, your whisper is...
And can detect, detection and things like that. But a lot of those are more video and sound, and then what do you do with that information once it's detected? And I like Marc's comment about predictive maintenance. There are some things that you could automatically do and some actions that can be taken with that data and that artificial intelligence, captured, that data being captured. But I think there's a lot of confusion in the industry. And I mean, I even get confused myself, especially when, like you said, talking to vendors. There's a lot of folks that are really more throwing that and attaching that term to some of the solutions that they have out there, but I just don't know what kind of concrete evidence that they have, or what are they really doing with it? And is it a marketing ploy?
Yeah, spot on.
There's a big, I think your comment on machine learning is important, because everyone thinks, again, we have this spectrum of things we call AI and ML. Training is the computationally intense piece in most cases, right? When you look at, now granted, evaluating video and audio signals is computationally intensive for even executing the models, but that's a good reason why, they may end up on the edge. But going back to this, it's like we focus on the algorithms that build up most machine learning are incredibly simple, right? The actual, when you're going to score a model or execute a model, that's why they can be run just very little computational requirement, right? It's the training that's the heavy lifting in most cases, at least in my experience.
But Rick, I would argue for certain types of data or content, but when you're looking at inference at the edge for, let's say, image recognition or video stream recognition, and you're trying to do it real time, then it can be very, very intensive, right? And so, yeah, and maybe one of the things I want to ask the team here, or the panel here, the group here, the coffee drinkers here, is why does AI make IoT any different? What's the big deal? Because, a while back I wrote this article, and it's called, "If you want to get value of IoT, forget about IoT." One of the points I make is that IoT is becoming so overloaded with any of the latest technologies, whether it's blockchain, or blockchain, or blockchain. It's just becoming a catch-all sort of buzzword, probably second to 5G and AI itself. Wow, it's like there's your closed loop, Stephanie. So I'd just like to throw that question out to the team. And David, you haven't said anything, so you need to say something now.
Yeah, so right off the bat, we must remember that if it's machine learning, it's probably written in Python, and if it's AI, it's probably written in PowerPoint. Okay, so that is easy way to make the separation. Now, Leonard, to your point of AI in IoT, there's a lot of automation that is happening to IoT systems, but it's tricky because, to Rick's point of how broad the spectrum is of when do we call this automation AI? When do we call this automation? Wow, my machine learning, program is really working because I clean the data. The data is solid. I wrote really good code, and it is training on what I set it out to train and learn from. And I think at the end of the day, it's there's a big chunk of the community that will fight the definition of what's ML, advanced analytics, BI, AI, cognitive, NLP, and what should you call what? Well, then there's a chunk of another chunk of the community that is just about the outcome. They understand AI, and they get to ask the questions of like, hey, vendor X, supplier X, you advertise AI, walk me through it. Show me evidence that this piece or that part, how are you leveraging artificial intelligence? And more often than not, if a supplier, if a vendor, if a friend is not able to walk you back from AI to machine learning to data acquisition, it's vapor. So that's how I feel about it.
You know what? I would agree, David. I think that the two themes I see as really getting us to that next level are, and you mentioned one, well, you mentioned both, automation and continuous learning, right? In machine learning, it's like X or Y. It's this or that. It's a little bit more simplistic, where I think from an artificial intelligence perspective, the algorithms are constantly learning, like you said, training, right? So there is continuous learning. There are things that are adapting, the flexibility in the system, whereas machine learning doesn't have a lot of those capabilities. And that's how we apply it to Internet of Things. The systems, the operations, the supply chain, the manufacturing execution systems, things that are actually doing things operationally, those things become more automated, more intelligent, and they're learning and adapting. I think that's the big difference. That's that's our goal, and that's where we want to go. And as you mentioned cognitive, right? We're learning things, right? That I think is the big shift in how we apply that to IoT.
By the way, Stephanie, you might have to repeat all of that because Your puppy is running back and forth in the background. So cute.
I didn't even realize
It's
that.
like a major distraction.
Springbok for a second. So
she has a lot of energy, so she's got to get it out.
Let's maybe also talk about what's unique about AI and the IoT, right? And
yeah,
I think that's super important. And when we talk about like some of the use cases Stephanie just mentioned, if you peel back the onion, a lot of what we're analyzing in business applications is actually processes, right? You're actually looking at the data generated by those processes. In the IoT world, AI initially was applied very heavily to assets, right? The physical thing and trying to predict failure or outcomes. Like what we learned in some of the work I'm doing now is that processes are just as important. And as the outgrowth of that is you transition from predictive, which is important for assets and to some extent processes, to prescriptive, right? So how can you train a model that says, this is the outcome I want? I want to, or the objective, I want to minimize energy usage. I want to optimize quality in this band or whatever. These are different kind of problems, and I think a lot of IoT AI practitioners have taken on so far. So I think that's an important growth area. And then the volume and diversity of data. Obviously, we're not short of data in the IoT. All these things are chattering off. The problem comes down to context. And we've already covered this, I think, in some of our previous podcasts, the importance of something, even if you don't buy into the term, the idea of a digital twin as the contextual point for all the data from all the streams that are relevant. Because it's not all just sensor data. It's data from business applications. It's data from many places. And ultimately, I think David was calling BS on the whole thing. He's right. These are all just they're just Lego blocks, right? There is no IoT. There is no AI. They're all just pieces of the puzzle for some digital transformation.
Yeah. Well, it's interesting that you brought up the digital twin. It's in this context, speaking of context, because it's almost like the digital twin is that digital half of sensor fusion, right? So you have all these different sensors or the cognitive feeds that are coming into let's say an intelligent system, right? In the core of the system, you're going to have some sort of metadata structure, and that, let's just, for the sake of discussion, call that the digital twin. And so this thing provides you with the structure for figuring out, okay, how do we treat all this cognitively sourced data coming in and giving a virtual view of the real world, right? And so I think there's a number of different layers. You mentioned the contextual data. You have AI there that is serving a cognitive purpose. So, the image recognition, the NLP, the audio sensing and detection type technologies and algorithms, those things are kind of serve as the nervous system, if you will, right? And so that AI supports that function at the edge. And as you start to come into the center of the intelligent system, then you have more of the analytical and reasoning type functions. But that digital twin really being a key structure to kind of bring everything together so that the system can start to make sense of things and then become contextually aware. And then hopefully at some point when the reasoning capabilities of the systems advance, then you can get to contextual understanding. And we talked about the need for contextual understanding in the smart home because it's lacking. I'll give you an update about my smart home journey. I connected my garage door to the internet. Totally useless. I haven't used it once, have not even thought of using it once, and I don't want to figure out how it works. I just want my data back.
And your $100.
Yeah. Well, no, it came with the house, so I'm screwed.
But sticking to to contextual evidence, here's and I won't plug anyone, but here's the thing: if let's just imagine a company that's doing very well on the with industrial assets, bringing visibility, bringing predictive maintenance, and yes, AI. Well, let me tell you something that shows evidence really quickly. If company A, I've helped an industrial manufacturer, let's go with electricity and let's go with vibration of assets. If I've been doing this for a while, my model has been learning. And I have context from assets, I have context from machines, I have context from the things that the process team asks, I have context from the things that the business and the engineer, I have all this non-machine context like Rick alluded to, right? So when I go to another prospect that has a different manufacturer, I'm going from, someone with CNC machines to a brewery, just to make it very different. There are things that application will show progress very, very quickly because of the previous learnings. And in it, there is this example of how AI does help these transitions from when I'm changing the assets. And there's a few brands, again, I'm trying to keep the plug here, that are doing very well and show evidence really quickly because they are doing these things, because these models have matured, and because they are leveraging AI to accelerate a proof of concept or accelerate when an existing customer, is bringing a new node, a new machine on. So it's for us as a community to ask of, if you really do these things, you should be able to give me a very quick example and stand up a very quick proof of concept in my factory with, let's pick a non-critical asset. And I try to share this line of thinking with, again, the folks, maybe there are buyers listening to this right now and they want to consume, AI or machine learning for their industrial applications. So these are some, things to ask. What do you do? What would you do in my context? And how quickly can you show me progress? And the ones that have been doing it, they can stand things up in a matter of, let's say, a week, and maybe, give them $1,000 because, we should pony up. We should put some money in the piggy bank for POC. So lots of evidence on the folks that are really doing it.
No POCs. POV. No POCs. Too many POCs.
I know, but sometimes it's scary, Leonard, and sometimes it's needed. If you have critical industrial control system, let's be honest, you don't want to touch them right away. But if we can show promise with something that's not critical in your environment, and then walk you through how we can securely do other things, there are.
Look, David. Just don't do no test, don't do low test, don't do crap code. Okay, and then you're good. All right.
And no POCs.
Yeah.
Okay.
But one of the things that I want to say is that, we hear a lot about predictive analytics and predictive maintenance. And I just want to note that this is not something new. We've been doing this for years, right? And it's really it kind of originates from statistical modeling, where you're trying to identify an algorithm. It tends to be, to your point earlier, Rick, pretty simple, but it's there to detect anomalies. It'll take a data stream and identify any kind of anomalous signals or patterns, and then kind of flag a dashboard that a certain asset looks like it may fail within certain parameters, or mean time, some sort of dynamic estimation of mean time between failures. So it's been around for a while. It's not magic, and there's people that are very good at it. But just want to dispel this notion that AI is some, quote unquote AI or some of the related technologies are something new. AI has actually been around since people started writing about it.
Well, what's kind of interesting is some of the early practitioners in that, it even wasn't AI, it was first principles modeling. So it was a true digital twin. You would have you'd say, this is the chemistry and physics of how this thing works.
Yeah.
But yes, and that was required a deep domain knowledge, right? I think that's what we're trying to get to now is an abstract set of problems. It says, it's just data to us. Yeah. Now, the reality is, as David points out, there's companies that go super deep. Like we know downhole pumps. That's what we do, or we know aircraft engines. And then there's the horizontal companies. It's still going to require a lot of, domain knowledge to make this stuff valuable and to validate what comes out of those models. Because sometimes it's garbage.
I would say too is AI has been around a lot, but some of the advancements that are being made are really at the chipset level.
Yep.
We did some research a few years back we've done a couple of them on kind of looking at what companies were doing really well with advancements with AI chipset technology, and what they're doing at that level that's where I think we're seeing a lot of just revolutionary changes, right? And SoCs and things that are happening at the chipset level. So when you are embedding this into hardware, there are things that are happening this year that we were never able to, the hardware was never really able to do on its own. And you're talking about as close to the edge as you can get, it's in the hardware. So there's some things that are happening at the hardware level and some advancements and innovation taking place that I think are moving the needle much more so. And I don't think a lot of people talk about that, because I think we talk a lot about software and applications and things like that. So anybody want to talk about what you're seeing in that space as well on the hardware side?
Yeah, I'll agree. So there's this whole trend toward heterogeneous compute that really got started with smartphones. I mean, smartphones really brought, in particular, one particular vendor or company brought neural networks into the smartphone SoC. And now we're starting to see convolutional neural networks now being run on microcontrollers, right? So now we're moving in that direction where now you not only have this AI or ML or DL inference capability on device. Now we're also starting to move toward more of a virtualized model for AI processing as well at the edge with like federated learning. So, Rick, you mentioned earlier how the model training is the big processor intensive or resource intensive piece. Now that stuff can be spread out. And so when you start to look at how the edge is going to evolve into this edge cloud, you're going to see all these different processing nodes across the network being able to kind of collaborate, share resources in training models, which is incredible because you typically associate model training to the cloud, right, or a large data center. And so that's that dynamic that's really changing. And so I think we're going to very quickly get to a point where the economics of all of this is going to create new ways for us to design intelligent applications.
One big danger, so that distributing training is super important in IoT. Hey, Rob. Because,
hey, Rob. Oh, man.
Because here's the deal. In IoT, the most dangerous thing we can do is train a model on the entire population of assets. The way a helicopter piece of equipment performs in a dusty environment versus a wet environment, or a pump performs in a concrete plant versus pumping beer. Second thing is, and this is where I really get worried about what we're doing with hardware optimization, is even the fathers and mothers of deep learning and neural network technology are basically the people sounding the alarm right now that we're doing it very wrong. Meaning the approaches that we take to neural nets and deep learning are fundamentally wrong. So the one risk is we basically end up taking current practices and making them solid and concrete and unchangeable if we don't start looking at fundamentally new ways to do it. Think how energy efficient the brain is in a typical day, how much processing your brain does on a small amount of energy. So we're still doing it wrong, and I guess that's the risk of just investing in hardware.
Are you saying that with some of the advancements that are being made, they're almost fixing the way things are supposed to be done across a broad spectrum, as opposed to providing the flexibility to adapt and do things in different groups? I mean,
I guess that's my fear. Maybe it's more, are we jumping too quickly and too many resources toward applied AI and not enough on the fundamental research side of it, right? I still feel like there's another 10 or 100 or 1,000 step change to be had there. It's just intuition. I don't know it to be factual, but it just sort of feels that way.
To comment on the conversation, sorry, because it's going so fast. David, did you ask for permissions to your customers to use the data from the sensors for models for the competitors? I leave that question, okay? And second, really, don't laugh. The second, it's related with what Rick was saying like 15 minutes ago. And it's that AI should go towards the direction of predictive maintenance, not prescriptive and probably proactive. And actually, that reminds me the business model chapter that we recorded some weeks ago, where I don't know if I explained that, but actually I tried to solve this model to a company that was making elevators. So actually, this is the fantastic use case. No, elevators should be managed with an artificial intelligence model to predict when they are gonna get broken or they wanna have problems, to save money, and even prescriptive technologies. So the technician can go there with the pieces that are needed, etc. But that became actually on an answer from all the elevator companies that I visited, saying, "Hey, we cannot sell that, because imagine that someone goes to your house and says, hey, we have to change this piece that costs some thousands of dollars from your elevator because it's going to get broken in a couple of weeks." So most of the neighbors are going to say no. So the elevator is working. How can you prove me that in 2 weeks it's worth it to pay the thousands of euros or dollars before it's broken? No. So it's getting into this moment now that it's very hard to create a business model behind this IoT and AI. Even on the paper, on PowerPoint, it makes a lot of sense, but it's really hard to sell it.
Yeah, you have to sell wizardry and magic.
Actually, a good example I think of this is what we can debate GE Digital and a lot of the things that they did right and wrong, but it was a very ambitious undertaking, and they actually got a huge amount of value inside the GE businesses. We don't talk about that enough. We look often at trying to build a software business. Again, let's not discuss or debate that, but their fleet of assets and their service backlog measured in billions, to Marc's point, they were able to create the business justification for the businesses and assets they already managed, right? It was almost a no-brainer when they did the math on the savings. But yeah, when you're trying, what's the famous science fiction line? Any sufficiently advanced technology is indistinguishable from magic, right? So people don't trust it until they're, it's well known.
Okay, guys, we're at the point in the recording here, the session, where we need to fill up. But Rob, you joined us late. Shame on you, number one. And number two, you have to explain to us what you have in the background, because you're showing more of it than yourself. And did Google pay you to wear that shirt?
Yeah, right. Yeah. So I'm just, I'm out in Eastern Washington along the Columbia River right now on vacation.
Nice. Look at this.
I assume this is some kind of talk. I assume you're talking about some kind of AI mystical stuff. Is that what?
Yeah. Dungeons and Dragons, Rob. IoT Dungeons and Dragons.
You know me. I'm the Forrest Gump of IoT, and so I don't try to, or as Clint Eastwood always says, a man's got to know his limitations. And so you never hear me talking about advanced AI or deep learning ever, because I don't know it. I used to be a data scientist when select star and stored procedures meant that that's what it was. Now apparently I'm not anymore. In IoT, I just say things like, I want to reduce unplanned downtime. I want to reduce, all those kind of things. I don't say I can prevent it because I don't believe that I can. Because I'm just trying to be practical, and maybe it's a little CYA, I think a lot of people overreached, with
Rob, we've moved backwards when we got away from SQL to Python, because now indentation matters.
Absolutely. Who would have thought?
Hey, just take a course. They have a bunch of online courses. You just invest a week and you'll be a AI guy in no time.
Absolutely.
So I would say too, guys, the other resource I use, which you guys might like and I love, it's Blinkist, and you could select your technology topics, and it essentially summarizes some of the best tech books that are out there in little short snippets, and I absorb a lot of information every morning by just listening to that when I'm getting ready or drinking coffee or whatever, but highly recommend it. A lot of good stuff in AI.
Yeah, but we have better stuff, Stephanie.
Don't forget IoT Coffee Talk.
Yeah. Okay, with that, thanks everyone for attending. It looks like we had a good quorum here. And for our listeners and our viewers, just comment. We'd love to hear your reactions and your thoughts on this session. You can find us on LinkedIn. We have a group there called IoT Coffee Talk. Just request to be invited, and we'll be happy to have you. And we also have it's Google. See, Rob, your fault. We have a YouTube channel. It's called IoT Coffee Talk. You can get there by just typing www.iotcoffeetalk.com in your browser, whether it's a Google browser or it's a Apple browser or whatever. It should take you there. And we'll see you next time. And by the way, hope everyone had a safe and happy, right? It's got to be happy 4th of July.
Awesome.
All right.
Cheers.
Good one, guys. Take care.
Bye.
Cheers.
Bye.